Okay, so we're still graphing sines and cosines, but now we're taking it up a notch. Now we're adding in a phase shift. So remember, here's our ultimate goal. Now we've got something inside here. Something added or subtracted inside the parentheses. Okay, so we're going to approach this just like all the other ones. First, we find our amplitude, which is always the absolute value of A. A is the number multiplying your sine or cosine. That's an S there, not a 5. That may have made it worse. So A here is 3. Absolute value of 3 is just 3. There's our amplitude. Our period, our new period, is 2 pi over b. Remember, for sine, cosine, secant, cosecant, always the same. New period's 2 pi over b. When we get to tangent and cotangent later, things are different. For now, 2 pi over b. B is the number multiplying x. So 2 pi over 2, which is just pi. Our phase shift. This is going to be our horizontal shift. We're going to grab regular old sine of x and scoot him over. Is always negative c over b. C here is this number added or subtracted. So opposite of c. C is negative pi. I'm going to write that. C is negative pi. I want the opposite of c. So pi over b. B is 2. Right there. This is going to be my new starting point. My new x-intercept for sine. Our vertical shift. K still equals 0. No vertical shift. We'll get to those in a later video. Okay, we do start and end. People that do start and end tend to get these right. People that don't. I want this inside. That equal to 0 equal to 2 pi. So 2x minus pi equals 0. 2x minus pi equal 2 pi. So I got to do a little algebra here. Move the pi over. 2x equals pi. Divide by 2. I get x equals pi over 2. That should always be your phase shift. Your start should always equal the phase shift. If it doesn't, you've done goofed. For sine and cosine, start equals phase shift. Okay, here. Oh, we got a little bit of algebra here. I got to move that pi over. I'm going to write that down. 2x will equal 2 pi plus 1 more pi. So just think like adding like terms. I've got 2 pi's plus 1 more pi. I've got 3 pi's. Then divide by 2. X will be 3 pi over 2. So there's my end. Now another check here. You should always check this. End minus start should always equal the period. So let's check that. 3 pi over 2, my end, minus my start. 3, forget about the pi. This is 3 halves minus 1 half. That's 2 halves. Or think like I'm counting pi over 2's. 3 pi over 2 minus 1 pi over 2 would be 2 pi over 2, which would reduce to pi. Is that what I got for the period? It is. Right there. Check. You'll catch a lot of mistakes doing that because a lot of arithmetic mistakes, especially with fractions, happen in here. Okay, last thing we find is our scales. Our x scale is the period over 4. My period was pi. So I'm going to be counting by pi over 4. I should probably make everybody pi over 4. My life is going to be much easier if all of my fractions have the same denominator. And I could use any, I could make all my denominators 400 if I want, or 60, or 100, or 8. The least common denominator between 2 and 4 is 4. So I'm going to write both of these guys over 4. So to get 2 to 4, I had to multiply top and bottom by 2. Same thing here. Multiply top and bottom by 2 so that I get 4 on the bottom. Okay, now we're ready to graph. We draw a nice pretty sine wave. I can draw that better. Hold on. We had no vertical shifts. Our x-axis comes right through the middle. That's our midline. Okay, who are we graphing? Literally, I don't remember. Was it sine or cosine? Because I didn't care for any of that. I'm graphing sine. I know sine starts and ends at places that look like this. So I'll use these. There's a start and there's an end. Start, end. I know what numbers to put there because I just found them. Start was 2 pi over 4. End was 6 pi over 4. And my scale was pi over 4, so I'm just going to start counting from here, going up and down, counting by pi over 4. So I'm at 2. Remember, I'm going to hit every crest, intercept, trough. So there's 2. Next would be 3 over 4. Then 4 over 4. I know a lot of these reduce, but please don't. 5 over 4. Hey, look what I hit next. 6 over 4. I've probably done it right. Okay, let's go backwards. I'm at 2. If I go backwards, 1 pi over 4. Going backwards again, I'll hit 0. Oh, 0 is something special. As soon as you hit 0, you're pretty much done. That's the y-axis. And you're usually just going to find it by accident. Okay, we keep going because we want to graph on both sides of the y-axis. We got to keep going. So we're going to get this next crest, negative pi over 4. This next intercept. Oops, I wrote a 2 there. This next trough. This next intercept. By the way, I want to point out here, a lot of times I see people and they go through and they label these points. Like they're writing their numbers. They'll literally write it up here because they think they're labeling a point. No, we're just labeling spots on the x-axis. All of my numbers here, ideally, would all just be parallel, all right here along the x-axis. Now, I don't expect you to be a perfect artist. Like if they're not perfectly in line, I'm not going to take points off. But we are labeling these slash marks. We're not labeling the points. Don't go up and down with your labels. Okay, the last thing we got to label, the one people forget, is the amplitude. I don't remember what our amplitude was. It was 3. So that our highest and lowest points, like right here, will be at 3, and down here, -3. And that graph is done, and that's a good place to stop.